Alright, so today we're going to be looking at perpendicular and angle bisectors. So we've already talked about some of these things before, but make sure you follow along and take notes and stuff. If we have perpendicular, that means two lines meet and form 90-degree angles if something's perpendicular. We talked about that before. We did it a little bit last chapter. And then we have angle bisectors.
180?
An angle bisector cuts an angle in half. We talked about that before too. So perpendicular is 90-degree angles. Angle bisector cuts an angle in half. A perpendicular bisector is kind of the combination of both of those. So if I have a perpendicular bisector, it means I have perpendicular lines. So in this example right here, this is 90, perpendicular means 90. And if this is 90, so is this. This is 90. And the bisector part means it gets cut in half. So this left half is congruent to this right half. If I have a perpendicular bisector, then if I take points on the end of my perpendicular bisector, and I connect them to some point on the actual bisector, sorry, if I take, okay, let me back up. Sorry, a lot of bisectors and perpendiculars in here. Okay, PM right here is my perpendicular bisector.
Okay.
A and B are my endpoints. If I connect for my endpoints to anywhere on the perpendicular bisector, they will always equal each other. So if I go from PA to PB, it is always congruent if I have a perpendicular bisector. And it doesn't matter where this point P is. As long as PA and PB, as long as they match up at P, it doesn't matter where it is, they always equal each other. So for example, if P was actually down here, and let me choose a different color, hang on. If P was actually down here, and we went from here to here, they would still equal each other. They would still be congruent. Doesn't matter where P is, they will always equal each other. PA will always equal PB. So, because of this, we can find missing pieces of triangles as long as there's a perpendicular bisector in there. So, anybody still working on these notes? No. Put that as a note. Alright. So, I'm going to look at this picture right here. I have a couple triangles. I have BAD, BCD, and I know that BD, right here in the middle, is a perpendicular bisector. And I know that because I have a 90, which means this is 90, and I have these two congruent pieces. I have this, and this is congruent. So basically what has happened is this thing has been, no, I meant to get the arrow thing now. One more time. There we go. So basically what's happened is this is a perpendicular bisector, but they've rotated it. So if I were to actually drag this around and kind of loop it like this, this is what it looked like in our last example. You can't really see the numbers well, but it's basically the same thing. So I've got my perpendicular bisector right here in the middle, which means I can find X, and after that I can find AB. The question says, what is the length of AB? So I know this is congruent to this because I have perpendicular bisectors, which means 6x minus 10 has to equal 4x. And it's just an algebra problem to solve for x. So if I'm going to solve it for x, Joseph, start us off. What do I do to solve for x?
Subtract 4x on both sides.
Let's actually subtract 6x. Because if I subtract 4x, I get 2x minus 10 equals 0. And it's kind of annoying. So it's minus 6x.
Equals 5.
You're on the right track, though. We're going to minus the 6x. I'm going to get negative 10 equals negative 2x. What's my last step? Ryan.
Divide by 2, negative 2 on both
And
sides.
what do we get?
5x.
We get 5 equals x. Pretty easy. Not a super tough problem. You guys have done harder than this. But we aren't quite done yet because the question asks, what is the length of AB? Did we find AB?
Yeah.
No. We found x. But AB is pretty easy to find. Because I found x is 5, I'm going to just take that, I'm going to plug it into AB right there, which I know it's upside down, but AB is 4x. I'm going to go 4 times 5, which is 20. 20 equals, and I'm just going to say AB. AB is 20, 20 equals AB, same thing. I think we're going to do one more of these, then you guys are going to try one. So, I'm going to look at this one, and I'm going to find the length of QR on this picture over here on the right. So, by looking at it, I have a perpendicular bisector right here in the middle, because I got 90, which makes this 90, and then I have my two congruent pieces already. Because I have my perpendicular bisector, I know that this kind of hypotenuse of my triangles can go into this hypotenuse, and I can set them equal to each other to find QR. So I know that this left side, 3n minus 1, is going to equal the right side, 5n minus 7, and it's just a big algebra problem. So Kylie, what should I do first?
minus like n3 on both sides.
Minus 3n on both sides?
Yeah.
Alright, minus 3n on both sides. And I get negative 1 equals 5n minus 3n is 2n. I still get this minus 7. Nick, what am I doing next?
You are taking
Yeah, I got it.
canceling out the -7 with the +7 and taking the +7 and adding it to the 7.
We're going to plus 7 on both sides. Come on. My tablet would work. There we go. Alright, and that means I get 8 equals 2n. Trista, what's my last step?
What?
What's my last step?
Divided by 2.
And what do I get after I divide by 2?
You get 4n, or 4 equals n.
4 equals n. Tyler, did I answer the question?
Pardon?
Did I answer the question it asked?
I think so.
What's the question say in this problem?
Yeah.
Find PQ.
No, up or above.
What is the length of Q9?
Did we find QR?
Oh, wait, it is.
It's on N.
You missed
Oh, I
it
know
though.
where you just found.
We just found n, right? So, we
I have
gotta
a
take this
question.
in and
It's
what?
supposed to
Are
be
you sure 8 is supposed to be there?
What's wrong?
Negative
Supposed
1
to be
plus
6.
7. 6,
Because it's negative 1 plus 7.
right?
Oh, oh, yeah.
Oh, yeah, 6.
Yeah. I thought that was, I mean, what are you talking about? That's not an 8.
I was a little confused.
I was
Yeah,
too.
me too.
I mean, it was totally 6. What are you talking about? There we go. So we get 3. That was my bad.
Negative 7.
Got that negative right there.
I already wrote it down.
Anyway,
Anyways.
we're gonna have to edit this before I put this one on YouTube. I'm gonna say, oh, the power went out, so then we restarted, and it's gonna be fixed. Alright, anyway, we get 3 equals n. Sorry, that was my bad. I forgot my negative. And now that we actually have an n equals, now we can find the final answer. So we're gonna plug 3 in for n up here.
No, not yet.
So 5 times 3 minus 7. 5 times 3 is 15. 15 minus 7 is 8. I get QR equals 8 for my final answer. Alright, first in class problem. On this bottom one here, I want you to find PQ.
Thank you.
Mhm.
Ooh, I do. Oh, that's fine. So fun. So fun.
So find PQ.
So fun. Picky.
Hmm.
Picky.
This is surprisingly surprisingly not melted for something that's been there since lunch.
That sounded full.
It's also been there since lunch.
That took me about 3 hours, 2 hours, 2 hours,
I wasn't worrying about it.
40 minutes ago. No, 20 minutes ago. No. 30?
Lunch was 2 hours ago, Ryan.
Yeah, and I'm saying 30 minutes.
It might just be out there.
2 hours and 30 minutes.
Wait a minute.
Yeah, I think I'm good. Just do it.
Yeah, I finished.
I'll give you another minute, then somebody's gonna do this on the board for us.
Can I not do on the board?
If you're lucky and the calculator doesn't pick you.
Okay. What if you're not picking?
Wait, you subtracted 5x from the second.
Yeah. Because you're making more sense because you're trying to find the positive non well. Okay, I have a question here. Which one seems more correct? Is mine. I got 5. You got -7.
Alright, let's look. Minus the 5x, and you got negative 3x minus 9. Plus 9. So you get 21.
Did I do this
21
right?
divided by 3?
I did not 5.
21.
It's negative
Okay.
7, God damn it.
There you go. Alright.
Is
Oh, that's
it
what I
negative
did.
or positive?
So I got PQ as 5. I already did that. I knew it was 7. It's just I got PQ at 5. He got
Wait,
PQ
negative
for
7.
Alright, so we're gonna start going over this one. If you're not done, keep working on it.
Negative 14. There you go.
Alright. Joseph, do the first part. Find X for us. We'll have somebody else do it. Joseph's gonna find X, so make sure you follow along, see if you got the same answer as you.
He got damn it.
Yeah. Make sure you pay attention to this, Ryan.
Otherwise, it's just going too fast for moments.
You just divided it wrong if you didn't.
Yeah.
No biggie.
No, it's really.
Yeah, it is a huge biggie.
It's not that bad.
If you're in
Way
huge
worse.
and good, yeah, it's a good time like that. It's a biggie. Wow, that's such a better handwriting than cooking sometimes.
My handwriting is beautiful. What are you talking about?
I know.
Alright, looking pretty good.
Oh, his handwriting or his
His work. His handwriting's not bad. I can read that.
It's shaky.
That's a plus.
I'll blame him. I blame him.
It's getting more shaky since I'm going now.
You're making him nervous. If you do a bad job, everybody will remember this from the lesson on YouTube and not my mistake. Just do a bad job, Joseph. I don't want them to remember my stuff. Alright, we get -7 equals, I think that's an X.
It's totally an X. That's totally a
Alright.
7.
But we are not quite done yet. We still have something else to do. Because it said find PQ. We haven't found PQ yet. And let's see, numbers at that desk. Oh, Quana. Quana.
Not done.
But not by me.
Why don't you finish it off? Alright. You got this. I believe in you. So, we haven't found PQ yet, but we found X, right? So what are we going to do to find the actual length of PQ now? So we're going to have to plug that -7 in for X up there.
So we're gonna plug -7.
Yep.
It's right there.
That's right there.
X up here.
Like that. And you can just do it off on the side somewhere. That's fine.
So
Yeah.
2x.
Yep.
Or no, 5.
To the PQ, so let's do 2. We'll get the same answer either way, but and then instead of X, we're plugging in what?
7. Negative
You
7.
don't.
Oh, that feels so weird.
You could save that. You could have made that a 7.
What? When you say
Really? We're restarting the whole thing.
Yes.
Kid.
That'd be hard to do. I'm actually not.
Might hit him.
I'm done.
Alright, so
Yeah.
we're gonna have 2, and then instead of X, we'll plug it in -7. Yep. And why don't you put a little time sign between that 2 and the -7, so we know it's a times. Yeah, just a little dot.
Put it in
That's fine.
parentheses.
Alright, that'll be fine. Okay, so we gotta go through and solve this, right? So what is 2 times -7?
Look at the picture in 20 seconds.
Sorry.
He's got it. Yep. -14. And we still have -9. So let's put that on there. Pretty good. Alright. And now I just have -14 minus 9.
Alright.
Which is,
Negative 23.
finish it off. Stick the landing. Or do something. You thinking it over, or are you freezing up on us? Right. All right, negative 14 decimals it real quick, if you don't know.
Negative.
Yeah.
This
It's okay, Kwana. That's how we learn.
Crazy. Ooh, I like that.
How we learn, by ignoring one. That'll help us learn. All right, you get negative.
What is that? Oh, just my mind.
There you go. Nice job. It's pretty enough, Kwana. It's good. What? Did you say you want to make it filthy?
Oh my gosh.
I don't even know what that means.
All
All right, nice job.
Isn't that crazy?
All right. That was the first part of what we're doing. The second part is actually going to be pretty similar. So, we are also going to be working with some bisectors, but this time they're going to be a little different. So we're going to be looking at some angle bisectors. So, I have in this, it's two triangles. It's not one big triangle, but it's kind of two of them. In this, I have line ray QS, bisects angle PQR, which is this big angle. And then, if I go from my two end angles, and I make a 90 degree, and I go to this angle bisector. So I have a 90 degree right here, 90 degree right here. If we meet them at our angle bisector, they will be congruent to each other. So if I do this, SP and SR are congruent. So if we have an angle bisector, and then we have 90 degree angles like on these outside corners, these little pieces on the inside will equal each other. So it's very similar to what we just did, but this time around, instead of having a perpendicular bisector, we have an angle bisector and then some perpendicular lines. But it kind of works the same way. So these two pieces will equal each other.
What about the then thing?
What?
Was there
Oh,
nothing under it?
it's this thing. Yeah.
Oh.
Hold up.
Little tiny thing. Then SP will be congruent to, or excuse me, will equal SR. Got it, Tristan?
Yeah.
Alright, so if I'm going to look at this shape right here, I have an angle bisector because of these little things right here. And I've got two 90 degrees. I have two perpendicular parts, which means inside this I have congruent segments. I know that this piece is congruent to this piece. So I can find out the length of RM, which is this little one right here, basically by doing what I did before. I'm going to find X by doing 7X is this first piece. It's going to equal 2X plus 25, which is this right piece.
Trust me, you can dance.
This one right there. And then we can solve it for X, and then we can plug that back in to find Rm. So if I'm going to solve for this, I think I'm at, Chloe, what's my first thing I got to do?
Oh, subtract 2x.
What?
Subtract 2x.
Yep.
Crazy enough
Minus
to do
2x.
anything like that.
On both sides, I'm going to get 5X. It's going to equal 25. I just got to divide it by 5 now. Make sure I divide this right this time. Did X equals 5. Alright, but Tiana, did we answer the question yet?
Nope.
Nope, what do I got to do?
Times it by 7.
Hey, what? You're so quiet. What?
Times it by 7.
So we're going to take this 5 and we're going to plug it in for this X, right? Which means we're going to times it by 7. So we're going to plug 5 in for X up here. 7 times 5 is 35, which is Rm. And then, alright, I think I got one last thing, last problem, and then I think that's it.
Oh my
I
god.
have a shorter one today.
That's so true.
Do you guys want to do one more practice, or do you just want to do the in-class?
And class.
In-class? Alright, I'll let you skip this one. You guys are sounding like you're doing pretty good. So we're gonna skip this one, go straight to your in class. I want you to find FD. Then somebody will do it on the board for us, kind of like we just did.
That was in class.
Oh my god.
Then after that, we're done. Do your exit ticket, and then we'll start your homework. So find FD. If you need help, I'll be around in just a second. Make sure I have your exit ticket done, because I forgot that from my last class.
Did you say 70 divided by 50? Oh, 15. What's this? What is it, 50? 15 or 50? 50. Alright, close.
For the exit ticket?
Is this one?
Did you answer the question?
No, not yet.
Not yet, but your X's looks good, so you
Okay.
can plug it back in.
Okay, cool.
I'll give you about another 30 seconds. I'll let people start doing it on the board for us. Alright, Kylie. Find X for us. Are you still with me?
Yeah,
You plug it back in. Trista, find X for us.
Yeah, 43.
Alright, Trista's gonna find X, and Kylie's gonna finish this off, so make sure you pay attention. See if you get the same answer.
I may need more room just because I kind of write big.
Hit the little blue down there on the side.
Wait. Then I need this.
No. No, you can just get it.
Okay, let's get it.
Got it. There you go. Click on it. There you go. Lots of room
Caution, you say that way.
there. Alright.
What are the length of A, B, and C?
You got it. So 5x plus 20 equals 20x minus 50. Looks good. So they will both equal each other because we have an angle bisector and we have two perpendicular pieces there.
Mm-hmm.
So just added 50 to both sides. She added 50 to both sides. We get 5x plus 70 equals 20x. Looks good. Then we're going to minus 5x on both sides. And you do take up a lot of space.
Get off my unicorn.
And we're going to get, after we minus 5x, 70.
Yeah.
And...
I mean, what's
yeah.
15?
Yeah, that should be a 15. There you go.
Quit. Please, no quill.
Good enough.
Yep.
Alright, and then we're going to divide by 15 on both sides. That's a 15x there. And we're going to get x equals, or something equals x. X equals 4.6. Nice job. Alright, and then Kylie, we're not done yet. We found x, but we have to find FD, I think it was. So I'll give you a second to finish it off. Ready? You got
No competition.
There you go. You're
Why
all
not
over
go
the place
split this
today.
crazy life and then eventually?
Alright, Kyle's gonna finish this off for us.
This down because just took up a lot.
I don't understand your
You
specific
did.
kind of crazy, but I do admire your total.
Just you took up like a page and a half.
Yeah.
in
Told
your
you already,
one
babe.
problem.
Be crazy, be stupid, be silly, be weird, be whatever, because life is too
Don't
short
say I
to be
didn't want
anything
you.
but happy.
That's fine, just keep going.
Oh,
Power
that
through.
one.
Alright, so we're gonna plug in 4.6 for x. So we're plugging into FD 20 times 4.6 minus 50.
Okay, fine. You don't have to be crazy.
She writes huge too.
I think that's what I got.
I'm
No.
not sure if I track
What is it?
crazy or if I
I don't
make
remember
it
off
out.
the top of my head.
Let me see, 80.
Yeah, how about
What's
that?
20 times 4.6?
40. I don't know, I Desmosed it.
Yeah, I know.
What?
Yeah. Yeah,
44.
okay, keep going then. Minus 50.
Alright.
Crazy doesn't even begin to cover. I got God damn you that weird.
And we get 42.
You made that one too.
I believe that.
Yeah, what'd you get, Trista?
I got 43. So
Yeah,
it's 43.
Yeah.
I got 42.
Crazy.
I got 43.
I got 42.
Alright,
That's
we're
what
gonna
it
have to
said
look
on
at
here.
this.
What's your crazy one in your listening?
Alright, let's Desmos this.
Your numbers on the back. Last name, inspiration,
Alright. 70 divided by 15. Okay, it's 4 point, oh, I bet, did you guys use 4.7 instead of 4.6?
No.
No.
I used 4.6.
6.
4.6.
4.66.
Let me see, what was it, 20 times 4, yeah, it depends on how you rounded it.
Maybe crazy.
So if we did like a whole bunch, yeah. And then, alright, so if you just did 1.6 here,
4.6?
yeah, if you just did 4.6, which you should have rounded to 4.7, you got 42. If you added more 0.6s though, it goes up to 43. So it's actually, adding more 0.6s is more accurate. So that's what happened. You either forgot to round or you didn't add enough decimals.
Yours does anything like that?
You should always round, always.
I never round.
So nobody, you guys just rounded it differently, you didn't have enough decimals, not a big deal. Alright, that's good enough though. So, we're gonna do your exit ticket next, if you haven't started on it yet. I will turn on Scrata in just a second, and then you can start your homework.